Welcome to a lesson with Dr. Powell. Let's take a look at this matrix and compute its determinant. This time we're going to use a process called method by cofactors or cofactor expansion. So this method uses the fact that the determinant, one way of thinking about it, is it's every you take every possible way of permuting the columns, say. Just stick to one, rows or columns. So if we do columns, we take every single way of permuting these columns, like rearranging the order of these, and then looking at all the diagonals that we get, and then multiplying all those diagonals up. We have lots of different products, and but then associated with each diagonal, you need to modify some of their signs. You need to modify this, like for instance, if I were to, so this is a column 1, 2, and 3. If I were just to switch column 2 and 3, so have like -1, -1, 0, 0, 1, 2, and then I have -2, -1, -2. So I just swap those. This is one switch away from the original. So every switch will change the sign of this product. So if there's only one switch, I've only changed the sign once, so it's going to be a different sign. So I would take this product and change its sign. So now this same basic idea, actually, if I did it with rows, I get the same products, the same sign products, in fact, and the same determinant. So it doesn't really matter if I do rows or columns in this particular case. But understanding that gives us, there's actually, based upon that notion and definition, there are many different ways of computing the determinant. And one of them is something called a cofactor expansion. How do we get all those signed products and kind of do it in an inductive type way? Well, in all of those signed products, you're going to have, there's going to be ones that have a, so if we just pick one column, let's just pick this column right here. There's going to be products that have this 0 in it. There's going to be products that have that 1 in it. There's going to be products that have that 2 in it. All right. So we can group those products as follows. All right. First of all, so it doesn't matter which column we pick. I just picked the middle one randomly. In fact, you can even pick rows to do this with, but right now let's just do a column. I just picked the middle column. We think, okay, how far is this away from the top right? Like, how many switches do you need to kind of move this guy minimally to move this guy to that position? Well, it's just one, right? That means that that what we associate with the 0 is going to be the opposite, is going to have an opposite sign. There's going to be a sign change. So I write down a 0. Now, in fact, it doesn't really matter what comes after the 0, but I'll just do this for completeness. The sign has changed, so there would be a minus here. And then what I do is I look at everything that's kitty corner to that 0, right? Because the only thing that can be grouped with 0 in these 0 would be -1. If I chose a -1, then it would be a 0. If I chose a -1, it would be a -2, and getting those signed products. But essentially, to get those signed products, it's the same as focusing on the determinant of what's left right here. If I just think of that -1, -2, and I'll use this notation for taking the determinant: -1, -1, -2, and 0. And to find the determinant of a 2 by 2 is actually pretty straightforward. It's actually, you take this diagonal plus, and then you subtract this diagonal with minus. In fact, those are the only two diagonals that actually occur in any permutation, since there's only two permutations: do nothing and then switch them. And one is a minus and one is a plus. So this one's really easy to see with that permutation of column idea. So plus that way, minus that way. Okay. All right. So I did that with 0, and I go through and I do this. I do the same technique for each of these. So for this one here, say how many switches to get to the top left. So I'm at the top left corner over here. So we have one switch, another switch. So that would be two, two switches. So change the sign twice. That's just didn't change, right? So plus. Even number of switches doesn't change the sign. So plus 1 times the determinant of what's kitty corner to it. So crossing this out and that out. Okay, this is the row and the column that this guy is in. I see what's left over. -2, -1, -2, and 0. And then I do the same idea, plus that diagonal, and then minus the product of that diagonal. Okay, and then going along that column, let's see. I have this 2 right here. And how many switches does it take to get this 2 back to there? Let's say 1, 2, 3, or kind of how long is the path? It's 3, which is odd. The sign is gonna change, so I can automatically put a -2 times the what's kitty corner to it. So eliminate the row it's in and the column it's in, and see what's left. -2, -1, -1, -1, and then we go across this way. Plus, and then a minus. And then as we compute, well, this guy is just 0 because it's 0 multiplied. So this one right here is plus 1 times, let's see, this is -2 times, that's just a 0, minus 2, right? So it's just going to be -2, so plus a -2 coming from here. Then over here we have -2 times -1 is positive 2, 2, and then -1, which would be 1 times -2, which would be -2. And notice that gives us -4 as our determinant. Now, little note, um, so this guy right here, see this kitty corner determinant thing that we came up with? Um, this is actually, you could call this the cofactor associated with the position where that 0 came from. This part right here, called the cofactor associated where that 1 came from. And this guy, you can call that the cofactor associated where that 2 came from right there. Thanks for watching.